Good day to you all. We're back again to solving physics problems, and now we will focus on fluid mechanics. So again, we have three problems which we all got from the University Physics book of Pearson, 4th edition. So now let's go into solving the problems. So for the first problem, we have here a hollow cylindrical copper pipe is 1.70 meters long and has an outside diameter of 3.90 centimeters and an inside diameter of 2.70 centimeters. How much does it weigh? So let us first now identify our given. So it is said that the pipe or the copper pipe is a hollow cylinder. Then we have a length of 1.70 meters, a diameter or the outside diameter of 3.90 centimeters, the inside diameter, which is 2.70 centimeters, and now we are looking for the mass. So what equations do we need to use in order to get the mass or the weight? So our density is equal to mass over volume, and so we can say that mass is equal to the density times volume. And now we have here our formula for the volume of a hollow cylinder, which is equal to pi times length times the outside radius squared minus the inside radius squared. So now let us get this. So first we need to convert our diameter into radius in order to get the volume of our object. And again, we converted our diameter into meters because it's only in centimeters. So now with 3.90 times 10 to the negative 2 meters over 2, which will give us a value for the outside radius of 1.95 times 10 to the negative 2 meters. Now for the inside radius, it's 2.70 times 10 to the negative 2 meters over 2, and a value of 1.35 times 10 to the negative 2 meters will be the result. We now have our radius, so we can now substitute it to our formula for the volume of the object of the hollow cylinder. So pi times the length of 1.70 meters times the outside radius of 1.95 times 10 to the negative 2 meters squared minus the inside radius of 1.35 times 10 to the negative 2 meters squared. It will give us a value of 1.06 times 10 to the negative 3 cubic meter. We now have our volume for the object, and it is said that the density of a copper is equal to 8,900 kilogram per cubic meter. So now we have these values, we can substitute it to our equation of M is equal to rho V. So M is equal to 8,900 kilogram per cubic meter times 1.06 times 10 to the negative 3 cubic meter, which is our volume. It will give us a value of 9.43 kilogram. This is now our mass and the weight of the object. So for our second problem, so ear damage from diving. If the force on the tympanic membrane or the eardrum increases by about 1.5 newtons above the force from atmospheric pressure, the membrane can be damaged. When you go scuba diving in the ocean, below what depth could damage to your eardrum start to occur? The eardrum is typically 8.2 millimeters in diameter. So again, let us identify our given so we can solve it easily and properly. So it is said that eardrum is circular, and we have here a force of 1.5 newtons. We have a diameter of 8.2 millimeter. And now we are looking for the height. So the equations we need to use in order to get our height is pressure is equal to the force all over area. And so we can say that force is equal to pressure times area. And the final pressure is equal to the initial pressure plus the density times gravity times height. So we can say that the change in pressure is equal to the density times gravity times height. And of course, because it is circular, our area will be pi r squared. So to solve for this, let us first again get our radius. So again, d over 2, so 8.2 times 10 to the negative 3 meters all over 2 will give us a value of 4.1 times 10 to the negative 3 meters. This is now our radius. So to substitute it, because force is equal to pressure times area, and we now have our values for pressure and area, so force now will be density, gravity, height times pi r squared. So just play with the formula and we can derive that the height will be force all over the density times gravity times pi r squared. So now we can just plug in our data. So 1.5 Newton times our density here is the sea water, because it is said that scuba diving in the ocean. So the density for the sea water is 1029 kilogram per cubic meter times our gravity of 9.8 meters per second squared times pi times our radius, which is 4.1 times 10 to the negative 3 meters squared. It will give us a height of 2.8 meters. So we can say that when we go scuba diving, this is the height of 2.8 meters is now dangerous to our tympanic member. For our last problem, an ore sample weighs 16.90 Newton in air when the sample is suspended by a light cord and totally immersed in water. The tension in the cord is 12.90 Newton. Find the total volume and the density of the sample. So our given, we have a force of 16.20 Newton. This is our weight. And we also have a tension of force of 12.90 Newton. We are now looking for the volume of the object and the density of the object. So the equations we need to use are, so the tensional force is equal to the weight minus the buoyant force. So we can derive it and say that the buoyant force is equal to the weight minus the tensional force. And our density is equal to mass all over volume. So we can say that the buoyant force is equal to the density times the volume times gravity. And we can say that a normal force is equal to ma. So to get our buoyant force, we need to just substitute our given. So 16.20 Newton minus 12.90 Newton should give us a buoyant force of 3.30 Newtons. Now let us find our volume. Our volume is force all over density times gravity. We got it from the formula of buoyant force of density times the volume times the gravity. And it is said that the density of the water is 1000 kilogram per cubic meter. So just substitute our given. We can say that 3.30 Newton over our density of 1000 kilogram per cubic meter times our gravity of 9.8 meters per second squared. It will give us a value of 3.37 times 10 to the negative 4 kilogram per cubic meter. This is now our volume for the object. Now, to look for the density of the object, we can say that the mass is equal to force all over area. So the mass is 16.20 Newton, which is our weight, all over the gravity of 9.8 meters per second squared. It will now give us the mass of the object, which is 1.65 kilogram. But now we are looking for the density, so we can just substitute it. So density again is equal to mass all over volume. So the mass of 1.65 kilograms all over the volume of the object, which is 3.37 times 10 to the negative 4 kilogram per cubic meter. It will give us a value of 4.90 times 10 to the third power kilogram per cubic meter. This is now our density for the object. That's all. Again, we solved 3 problems, and I hope that it helped you in different ways. So if you have questions, you can just comment or send email. That's all. Goodbye and have a nice day.